Let's take a look at this problem together. It says that we have three blocks, A, B, and C. Each have a mass m and are connected by strings as shown. Block C is pulled to the right by a force F, and that causes the entire system to accelerate. Neglecting friction, what's the net force acting on block B? Well, it's kind of an interesting problem. There's a couple ways to approach it. I'm going to approach it in the way of doing three different free body diagrams. So I'm going to have a free body diagram for block A, and it's going to have a couple different forces. Well, the first thing is I don't have to worry about friction, and I can look and see that in the vertical direction, everything's going to cancel out, and I don't need to really worry about it. So even on block B, the net force in the vertical direction is 0 because it's not accelerating in the vertical direction. So I'm only going to look at the horizontal direction. And I'm going to label some tensions. I'm going to say that block A has a tension force TA on it, or T1 on it, T1. And it pulls to the right. Block A is being pulled to the right by the string. There's no other forces on it, so that's my only free body diagram. Now if I look, and that was for block A. For block B, on the other hand, the one we're really interested in, we'll see that block B has two different forces pulling on it. It has a tension force 2 pulling it towards the right, and it also has a tension force 1 pulling it back. Block A is causing a tension in the string, which is causing block B to want to be kind of pulled backwards. We expect T2 to win out over T1, and the block's going to move forward. However, we don't know that yet. We'll see what happens later on. And finally, in block C, we have our applied force acting on our block, and again, we have a backwards force due to the tension in the string. So now when I work out these free body diagrams, I can see that my net force is going to give rise to my acceleration. And all of them are going to have the same acceleration because they're all going to be connected by the string, and we assume the string does not stretch at all. So our net force, I'm going to say positive is to the right. My net force is F minus T2 is equal to MA. And this is M, the block C, but they all have the same mass M. Block B, on the other hand, its net force is going to be T2 to the right, T1 to the left, so we get the minus sign, and that's going to equal MA. And finally, we're back to block 1, and we'll see that T1 pulls towards the right, and this is equal to the acceleration in the A direction. So now I have all my equations, and I'm going to start combining them. Well, anytime I have T1, I can put an MA in there. So I'm going to rewrite this equation. It's going to be T2 minus MA is equal to MA. My tension force 2 minus my tension force 1, which is just MA, is equal to my MA original. So these guys just follow directly down. I can rearrange this equation and see that T2 is equal to 2MA. I have an MA here and an MA there. They add together when they're on the same side. So I get a second equation, or equation that says T2 is equal to something. Well, I'm going to just go ahead and move over to this last equation and see where this takes me. And I'm going to see that I get F minus 2MA is equal to MA. My force minus 2MA is going to give me MA. So this is T2, that's my minus 2MA. So this is my force is equal to 3 mass times accelerations. So what does this give us? Does this solve for anything? Well, we can actually use this equation to solve for it. F over 3m is equal to A. And we want to know the net force on mass 2. So if I know that mass 2 is accelerating with this acceleration, then all I know is that my net force on mass 2, or on block B, I guess, on block B is going to be equal to the mass times the acceleration. Well, my net force is equal to mass, and my acceleration is F over 3m. And we'll see that the mass cancels with the mass, and I'm left with F over 3. It's a little bit of an involved way to get here. I solved the free body diagram, substituted it in, solved for the acceleration, and then since I was looking for the net force on B, I know that the net force gives rise to my acceleration, so I just plug in what my acceleration is that I already solved for, and I can figure out what my net force has to be equal to. So I see that it's, in my choice answers, it's choice B. It's F over 3. And this kind of makes sense. If we go back and think about it, all three of these blocks are each of mass m. There's one force pulling all three of these together, even if we don't include the masses together. If we think this is just one giant object, well, that would kind of mean that a third of it goes to moving this block, a third goes into moving that block, and a third goes into, well, it's actually accelerating all these blocks. So this answer makes sense to us. This little inspection at the end is only there because the blocks happen to be the same mass, and it's easy for us to kind of logically reason through it. So F over 3 is our answer.